Well, hello everybody. It's time to talk about graphing quadratics. Today we're going to talk about how to graph quadratic equations that are in intercept form. To kind of lead you toward intercept form, first thing I want to talk about is standard form graphing and how we can relate that to intercept form. So on the screen right now we actually have a standard form graph. Remember, that's a graph where we're of the form y equals ax squared plus bx plus c. So for us, notice again that a is that coefficient of x squared, so it's the number in front of x squared. So a equals 1 for us right now. 2 is the number in front of x, or the coefficient of x, so b is equal to 2. And c would be our constant, so c right now would be equal to negative 8. Negative 8. Now, we've previously talked about how to find the axis of symmetry and the vertex and that max or min value for this graph, and in fact whether or not it'll be a max or a min. Again, since a is positive, we know that it's going to be a parabola that's going to open upwards, right? Which means it'll have a lowest point, so it's going to be a minimum value. But again, to get those values, we could go that long route of saying, all right, well, negative b over 2a, x equals negative b, so for us it would be a negative 2 over 2 times a, or over 2, is negative 1, which means our axis of symmetry will be x equals negative 1. Our vertex will be negative 1 comma y. And again, if we can find that y value, then we can identify our minimum value, and we'll have all of that information. Right? So for that, again, we'll take our negative 1, we'll plug it back in. Y equals negative 1 squared plus 2 times negative 1 minus 8. And again, we would have 1 minus 2 minus 8, or negative 1 minus 8 would be a negative 9. So we're going to say that's negative 9. Our minimum value would be that y equals negative 9. And we could plot our vertex, right? It looks like I'm going to probably have to count by 2's on here. So let's go ahead and say this is going to be 10 and 10. So I'm going to go to negative 1, negative 9, and I would plot my point right there. Again, with an axis of symmetry running right up the middle, hopefully a little straighter line on your screen, at x equals negative 1. Now, we can find all that information in that long, drawn-out way of doing standard form, but what I really want to look at is relating standard form back to another form that we know, and that's factored form. If I think about what adds to positive 2 and multiplies to negative 8, I can come up with, hopefully, a couple of factors. Remember, that's where we're going to set up two separate sets of parentheses. X times x, if we were distributing, again, is going to give us that x squared, that first term. And if I can come up with two numbers that multiply to negative 8 and add 2, I can complete these two binomial factors. Well, I'm thinking that 4 times negative 2 would give me negative 8, and 4 plus negative 2 would be that positive 2 in the middle. So my two factors would be x plus 4 and x minus 2. And if we take advantage of the fact that we know in factored form, if we have an equation set equal to 0, then x plus 4 and x minus 2 will essentially give us a way to solve our equation as well. Two products, right? Sorry, got some random writing there. Two product, or a product, x plus 4 times x minus 2 of two things equal to 0 means that either x plus 4 equals 0 or x minus 2 equals 0 will give us solutions. So if I subtract 4 over to the right side, or I add 2 over to the right side, I've just found two solutions when my equation equals 0. And what I want us to realize is, well, that means that if y were equal to 0, what we really just found were a couple of x-intercepts, or zeros of my function, okay, as we sometimes call them in algebra. So I know that my graph is going to cross the x-axis, right? Is going to cross the x-axis at negative 4, because when y was 0, x was negative 4 would be a good solution. It's also going to cross that x-axis at 2. So I could plot those points at positive 2 for us on our graph. And at negative 4, 2 is 4 on our graph. And notice how they are perfectly symmetrical around that axis of symmetry. In fact, if we had found those numbers first, we could have averaged them. We could have said that, hey, negative 4 plus 2 over 2, well, negative 2 over 2 is negative 1. And remember, that's that axis of symmetry, right? Negative 1 here. That's perfectly halfway, right, in between those two x-intercepts. So that's why oftentimes we call this equation here, y equals x plus 4 times x minus 2, intercept form. If we can use the two factors to find our two x-intercepts, or our two zeros of the function as we often call them, we can average them together to find the axis of symmetry, and then we can continue by again finding the vertex, and we're well on our way to finding our full graph. Again, we would also need a couple of more points. Again, plugging in 0 is always a good idea. 0 squared plus 2 times 0. If I plugged in x was 0, I'm pretty sure I'm going to get negative 8. So I'm going to say that that's down here at negative 8. If I use my symmetry again, just like my zeros are equally symmetrical around that green line, my 2 points here would be, and again, I can graph, hopefully, a little smoother parabola than I just graphed. Hopefully you'll get a better looking one than that on your page. Now, all of that explanation was very good as far as a review goes, but the big things I want you to remember is that if we're looking at intercept form, again, it's this form right here on our page, two factors multiplied, right, rather than being FOILed together or distributed together, we're going to leave those in factored form, because what that tells us is whatever can make either of those equal to 0 would be the intercepts, right? These two red dots on our graph, the x-intercepts of our graph. And halfway between the two intercepts will be our axis of symmetry. So for the question up top, it's in factored form. Now you might be tempted, like I said, to distribute or FOIL that together. Don't do that. Again, the idea is we want to find our x-intercepts and we can use those to get the vertex. So the first thing I'm going to identify is that if y was 0, right, for y equal to 0, that means that 0 equals x minus 3 and x plus 7. So either x minus 3 equals 0 or x plus 7 does, and x would be equal to 3 or x would be equal to negative 7 are going to be my two x-intercepts. Right? So those are my x-intercepts. That was some bad handwriting right there, huh? X-intercepts. And if again we have our x-intercepts, we can average the two of those, because halfway in between again is going to be my axis of symmetry. So the axis of symmetry can be achieved if we say x equals, again, equations represent lines, x equals negative or positive 3 plus negative 7 over 2, which would be negative 4 over 2 or negative 2. And my vertex is halfway completed then, negative 2 comma, I just need to find the y coordinate. And again, to do that, we can go right back to our original equation, even in factored form. Y will equal negative 2 minus 3 and negative 2 plus 7. So we can say that y equals negative 5 times 5, or y equals negative 25, which will get me that x coordinate, or sorry, y coordinate of my vertex. So negative 2, negative 25, and because we know that that leading coefficient, notice the number out in front here, is positive, that's a positive 1 right now, we know that our parabola opens up, and this is actually also a minimum. So we can get all of that information again without being in standard form. We can get that all from intercept form. So let's take another look at it, one more example of how we can fully graph only being in intercept form. Okay? So you'll notice over here at the left, we've got an intercept form, a factored form equation. Okay? So the first thing we want to do, if that's the case, if we're in intercept form, is identify the roots. So if you want to, feel free to pause the video now, and you can write out all this information and see if it matches up with what I come up with here in just a second. So again, looking at those roots or zeros, I want to say what would turn these two things, these two equations, these two factors equal to 0. And I know that 5 minus 5 would be equal to 0, so I'm going to have one root at 5 comma 0. Right? If x were 5, then we would get back 0. And for the other one, negative 1, should turn that into 0. Again, remember, we're separately plugging in 5 and negative 1. If x were 5 both times, the entire equation, right, would turn to 0. It wouldn't matter that 5 plus 1 is 6, because 6 times 0 is still 0. And times negative 2 is still 0. Now, that means the axis of symmetry is going to be halfway in between those. So let's go ahead and do the work here. X equals 5 plus negative 1 over 2, or 4 over 2. X equals 2 will be my axis of symmetry. My vertex will be 2 comma whatever my y coordinate is. And again, to find that, we can just say y equals negative 2 times 2 minus 5, right? We're going to plug that 2 in there. So that's going to be a negative 3. And 2, again, plugged into our equation, 2 plus 1 would be positive 3. Negative 9 times negative 2 is a positive 18. And that will be my y coordinate for my vertex. Which also, again, because this is a negative 2 in front, we know that that's going to tell us our equation, right, is going to open downwards. Right? And this will be a maximum at 18 then. Which means I'm also going to have to count by some fairly large numbers. To fit that on my graph, I better count by 4s. That way I can reach up to 20 here. So I'm going to have a vertex, which I think I can probably get away. Again, 5 and negative 1 and 2. Thinking about those x values, I think I can probably still count by 1s. I'm going to plot a point at 5, 0. I'm going to plot a point at negative 1, 0. We're also going to have a point at 2, 18. So again, 4, 8, 12, 16. 18 will be halfway between that and 20. Again, looking pretty symmetrical. If we want to get that axis of symmetry on there at 2, it wouldn't be a bad idea. So let's see if I can draw a little bit straighter this time. It's going to be right there at x equals 2. And in that case, hey, I've got 3 points, right? I've got the vertex up here. I've got my 2x intercepts. I just need probably a couple more points to give myself an accurate graph. So we can do that by just, again, kind of constructing a table. We could plug in a couple other coordinates. Right? Wouldn't be a bad idea. So let's plug in maybe at x is 0, and maybe I'll even find a point at x is 1. And then we can use some symmetry from there. So when x is 0, and this is going to be a little bit of work because we're not in standard form, but that means that this is negative 2 times 0 minus 5 times 0 plus 1, and we're going to end up with 10. So at 0, we're at 4, 8 is 10. And again, that's 2 lines from my axis of symmetry. So I should have another point over here at 4, 10. And if I wanted to plug in 1, that's just going to be a negative 2 times, again, 1 minus 5 would be negative 4. 1 plus 1 would be 2. And we get positive 8 makes positive 16. So we'd have points here and here. If we graph our line really quickly here, we can get ourselves a decent looking parabola. One last note for you as far as graphing in intercept form goes. Again, as far as parts of our graph, we want to note, again, what we're saying is we can start with our roots or our zeros here and here. Halfway in between is our axis of symmetry. And again, on that axis will always be our vertex. So again, all of those are very important parts to our parabola. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.